Hello Year 12 chemists, welcome to TP's Chemistry Cuts. In this clip we go through the calculation of an unknown concentration using titration data from a 2-to-1 acid-base reaction.
So, what I've done is I've put up a set of results for a 2-to-1 titration. Okay. The actual reaction is the reaction between sulfuric acid, which is a strong acid, and ammonia, which is a strong base. And you can see it looks a bit odd on that side. It's not what we normally get. We don't get any water from this one, but it's still an acid-base reaction. And what we need to focus on is the ratio here. So this tells us for every mole of sulfuric acid, I need 2 moles of base. So we call it a 2-to-1 titration. In the actual assessment, during the practical, you will need to measure all the volumes and do the calculation for a 1-to-1 titration. Okay? And then part B of that, so you do it at the same time or afterwards, you need to do a 2-to-1 calculation where we will give you all these results. Now, if you make a mess of that, that is not the end of the road for you. You get a second opportunity in the next paper. You've got another paper to sit on the background theory calculations. You remember we did some mass-to-mass calculations initially? Well, that's one of them, and there are some others to do. Well, in that paper will also be a 2-to-1 or 3-to-1 or 3-to-2 or whatever calculation for a titration. So if you've made a mess of the first one, you get a second opportunity. Okay? Right, so the first thing we need to do for this is exactly the same as for a 1-to-1 titration, and that is to decide which of these volumes we're going to use and which not. And we should be at the point now where we can easily spot that this one is very different to those. That's the rough titration. So mark it clearly that you're not going to use it. And it is really important you do not use a non-concordant result in your calculation of average. Some people sometimes think, oh, I'm just going to put a cross by it, but I'll still use it. Okay, we don't do that. So we're going to use those 3. Okay, so let's quickly calculate the average. If somebody could actually do that for me while I'm writing it up on the board. Thank you very much. And that's mils. Okay, and to remind everybody, you need to quote every measurement to 2 decimal places. Okay, and your final average should be to 2 decimal places as well, because that's the accuracy of the measurement. This is not compulsory, but this is what I think is a good idea, is to identify which is the known and which is the unknown, and then assign all the values that you've got so that they're all nice and neatly laid out for your calculation and you don't mix anything up. So if we look here, it'll be quoted, look for where it's telling you the concentration, that's our known. So our known is NH3, and that makes H2SO4 our unknown. Okay, so let's do the volumes first. The known volume is in the burette, it's the base, so it's this. Okay, so it's 20.30, and we'll convert it into litres like that. Okay, so the other one is going to be 25.00 over 1,000. Okay. Those are the 2 volumes, and then the concentration of ammonia is 0.165 moles per litre, and the unknown, of course, is a question mark. That's the whole point of the experiment. You will be given the equation. You don't have to balance it or anything. It will be a balanced equation, but once again, what you're looking for is the ratio. So for every one of these, I need 2 of those. Okay, so that's our mole ratio, 1 to 2. So when I start talking about mole ratios, those are the numbers we're looking at from the equation. Okay, that's what we're going to drag down into our calculation. So the first thing, once we've got this equation, because that's given to you, the first thing we need to do is to calculate the amount of the known. So we're going to calculate the amount in moles of the known. Okay, we've been given a volume, we've been given a concentration, and so if we use our formula, which we've written up on the top of our page to remind ourselves, then the amount of the known is the concentration times the volume. Okay, so calculate the amount in of the known. So we look at our table and we know that our known is NH3 and that's C times V. So C is 0.165 times the volume, which is 20.30 over 1,000. And again, if somebody could tell me that.
3495 to the power of negative 3.
349, did you say? So that's 35
Yeah.
times 10 to the minus 3 mole. So once again, round it to three decimal place, or sorry, three significant figures when you write it on the page, but don't round it on your calculator. Leave that number in the calculator. So that's our known, that's our K. The next thing is to relate the known to the unknown using mole ratios. And it's this point where we go back to this equation. This is telling us for every one of those, there's going to be two of those. So in other words, for every one of the unknown, you're going to need two of the known. Okay? So if we're looking at the mole ratio, the best ratio is to do known, unknown to known, as you'll see. So if we write that down, N unknown divided by N known, those two numbers are the numbers we're going to get from the mole ratio of the equation. 1 to 2 are unknown to known. Okay? So our unknown is equal to 1, our known is 2. Just to remind you, or to highlight it, that bit goes there, and that bit goes there. Okay? Now, this is where there's a little bit of algebra and everybody starts freaking out. You need to cross multiply this because what we want to know is how does the known relate to the relate to the unknown. So if we move this across here, what we'll get is N unknown equals 1/2 times N known. Okay. So our known is N of, our unknown is NH2SO4 is equal to 1/2 of NH3, which is 1/2 times 3.35 times 10 to the minus 3, which is equal to 1.63 times 10 to the minus 3, I hope. That's rounded to three significant figures. Yes?
You're using that number on your calculator still though?
Yes, so you would use the number that's on your calculator, divide it by 2 here, okay, and keep it on your calculator, don't round it. Okay, so that's R for our ratios. Now we've got the number of moles of unknown. We know the volume it's dissolved in. We can calculate the concentration of the unknown. Okay, so calculate so our unknown is H2SO4 is equal to N over V. We've just worked out N, which is And again, I've not put in units. You must put all units in. If you've left that off, that would have been, if it was the only one you left off, it would have been a resubmission. But you want to make sure you're putting your units all the way along. Okay, so n is 1.63 times 10 to the minus 3, and v from our table is 25 over 1,000. If somebody could calculate that for me.
0.0825.
And that's 3 significant figures. So that's calculating our unknown, and that is our significant figures. Is there any part of that you want me to go through again? It's really important to get this right, because you have to get one of these right to get excellence. Yes? You want me to go through the ratio of moles again? Yeah. So what this is telling us is for every 1 mole of the unknown, which is H2SO4, we need 2 moles of the known. So if we look, just take a simple ratio, okay, of known to unknown, or unknown to known, which is what I'm writing here, unknown to known, I'm just taking 1 of the unknown here to 2 of the known. So always write n unknown over n known, work out which one it is from that equation, which one's which from that equation, and just use the number in front, because that's what the ratio is telling you. So what this is saying is I've got a 1 to 2 ratio of unknown to known. And so just rearranging it.